Made in Damascus is a research project that explores a method to study post-conflict regions by building a subjective personal map of a city to augment the study contents for the regions. For post-conflict regions that suffers from lack of resources and waiting for community reconstruction, how can we approach the site that is lack of context and records of histories caused by the conflict? To tackle the missing context, we start by looking at the discrepancy of our image of a city in digital and physical reality. In digital reality, city is a combination of stereotypes built up by history and a top-down perspective. While in physical reality, although we will miss statistic overview, we start to see the components and details that physically compose the city. Therefore, it is necessary to study the matter as a static element of the city so as to understand city on a more personal scale and more related to our everyday life. And thus, the project aims to use a personal inventory of the matter of the city and city data to generate a personal city map by machine learning. To approach this, we'll build a machine learning-based mechanism that can generate a subjective map of a city based on his or her image of the city. Firstly, a subject is asked to take as many photos as possible representing the image of the city in his or her mind. The subject went through some of her most visited places and take a journey to take photos that she thinks represent the city and she feel home. Then those elements are further cut out for later image segmentation. For a machine learning model to function correctly, we need much more photos for the training. So we augment the training set through image augmentation of those elements in random street images and patterns. The item will be automatically marked out and used to train a model for machine learning pattern recognition. The goal of the training is not to recognize the exact item, but to allow recognition of the pattern in a street image. Then we can scrap through available Google Street images in Damascus and convert them into perspective images recognizable by the model. The trained model correctly recognized the traditional extruded balcony, the stone patterns, and particular patterns of metal gates. It can also misrecognize some items that have similar pattern language, such as carpet that share the same pattern language as the metal gates, or the shop front that are seen as a balcony. It could miss some elements due to lack of pattern similarity, such as the standardized metal frames that don't have similar formal language suggested by the subject. Together with the metadata of the street map, a map highlighting the recognizable street image can be generated, which represents how those areas meet expected image of the city. The map can smartly distinguish which place has higher relevance and which has less relevance to the subject, according to how many objects are recognized here. Also, this allows us to link the visual to typologies of the place. The results surprisingly fit the subject's expectation of what areas might be extracted, those areas including where she went, where she works, and where she lives. We take this model in different cities and we can see dramatic decrease of recognition rate. For example, in Vienna, where the streetscape is totally different. But interestingly, in a city that has similar craft, the source of elements will have mildly more recognition rates. This approach allows the participatory activity to connect residents of a community and the city. So we can ask the residents of the region to select ideal balcony elements, and we can build a map of similarity that portrays the potential urban profile of the community. We can also use it to augment the study subject collected from the community. We take intact balcony around the site and feed them to the model, and repeat the process of training and image segmentation. Then we build a map linking physical community and the city. With more data such as interior photos and labels of zoning, we can have more study data. For example, interestingly, in Damascus, those recognized areas around the suburb have workshops that produce respective items that we selected. Matter, as a static element of the city, can reflect personal and collective images of their everyday life in the city. There's a critical relation between personal reading of the city's material and urban typology. Therefore, by integrating data mining and machine learning, the project manages to combine the materiality of individual and urban scale mapping, which provides a way to augment the context of the study and post-conflict regions with care to individuals and communities.